Hi, good afternoon. In today's video I will try to solve exercise 4 of model 3, discrete time Markov chains, and without any further explanation, let us begin. The exercise tells us to consider a 3-node token-based network with slotted time. In this network, token processing gives the right to transmit data over the ring on a given time slot. We assume that both the token and the data circulates in the clockwise direction. Consider that when the first node has the token, it decides to keep the token for the next round with probability 0.5. The second and third nodes keep the token for the next times with probability 0.2 and 0.7 respectively. Initially at time slot 0, node 1 has the token. And the first question consists of considering obtain the probability that the second and the third node will have the token in the first, second, and third time slot. Well, in the first, we have to consider this vector, probability vector, and in order to obtain p over 1, we have to multiply p over 0 by p, which is this matrix. And if we do it, I prefer to do it in fractions. Okay. This should be 1/2 So 1/4 here should be 1/2 times 1/2 plus 1/2 times 1/5, which equals 7 divided by 20, and lastly 1/2 times 4/5, which gives us 2/5. And now, if we multiply all of them, we should get 1. Yeah. And for the next part, to obtain p over 2, we have to multiply p over 1 times p. And I will do it here. 1/4, 7/20, 2/5. And the probability vector should give us this. Plus 2/5 times 3 divided by 10. Then 1/4 times 1/2 plus 7/20 times 1/5 and lastly 7/20 times 4/5 plus 2/5 times 7/10, 14/25. Okay, so let us sum all of this just to be sure. Okay. Now, the question B will be to obtain the stationary distribution for this DT and discrete time Markov chains. In order to do this, we have to take into account that the sum of the pi's will be 1 and pi times p will be equal to pi. Okay, so pi a, pi b, pi c would be equal to times the matrix P will be equal to pi A, pi B, pi C, and pi A plus pi B plus pi C should be equal to 1. Then we put the matrix P. And now we get that pi A divided by 2 and plus pi C divided times 3 over 10 will be equal to pi A, pi B, pi A divided by 2 plus pi B divided by 5 will be equal to pi B, and pi C would be equal, no, pi B times 4 over 5 plus pi C times 7 over 10 will be equal to pi C. And we have to discard one. I'll discard this one. And we get that pi A divided by 2 will be equal to pi C divided by 10 times 3. So pi C will be equal to 5 over 3 pi A. Pi A divided by 2 will be equal to pi B times 4 divided by 5. So pi B will be equal to 5 over 8 pi A. So pi A plus pi A 5 over 8 plus pi A 5 over 3 will be equal to 1. And pi A must be equal to 1 plus 5 over 8 plus 5 over 3. Answer the inverse of it. Pi A should be equal to 2479. 2479. Now, answer 24 divided by 79 times 5 over 8. 1579 will be pi B, the probability of pi B. And for pi C, it will be 24 divided by 79 times 5 divided by 3. So 40 divided by 79. And the last question asked us to compute the probability that each node possesses the token at time slot 10 and 100. So due to the fact that pi to the 10 and pi 100 are large numbers and large computation of this formula, we can say that it almost equals the steady state vector. So there's no need to do any computation because it will be tedious. So This is the end of the video. Thank you for watching.